Okay, I'm going to show you how to get these pi equations here. You know linear equation for velocity, 2 pi r over the period to go around a circle one time. And you know your circular motion formula for acceleration, AC, is v squared over r. It's just a simple substitution to derive this all out. So AC is going to end up being v squared. So that's 2 pi r, 2 pi r over t squared over r. So there's my v squared over r. Now I'm going to go AC. I'm going to square everything in there, so that I'm going to get 4 pi squared r squared over t squared, and that's all divided by r. So AC then, I'm going to bring this down, so I'm going to get 4 pi squared r squared over t squared r. And I'm going to cancel out this squared and that radius there, so that's going to give me my AC is equal to 4 pi squared r over t squared. That's for your centripetal acceleration. If you wanted to do centripetal force, you just take this thing and you times by mass. So 4 mass pi squared r over t squared. So those are your 2 pi formulas. Okay, it just saves you a step because I've just combined these two. You don't need to know these. You can just go find your velocity first and then plug them in. It's up to you. Okay, let's do an example. So I've already got a nice example written out for you here. It's going to be the moon traveling around the Earth in a circular orbit. It's nearly circular, but for this question we're just going to say, it's got a circular orbit of 384,000 kilometers. The period of one single orbit is 27.3 days. We're going to find the acceleration of the moon towards the Earth. So we're trying to find AC. Let's write down our info. Radius, 384,000 kilometers. Don't want kilometers. I want it in meters. So that's going to be 384,000 times 10 to the 3 meters. I also know that the period is 27.3 days. Well, I can't use days for anything, so I'm going to have to convert that to seconds. So 27.3. There's 24 hours in a day, there's 60 minutes in an hour, and there's 60 seconds in a minute. Multiply that all out, you are going to get a time of 2.36 times 10 to the 6 seconds. So now we've got things in meters and seconds. I like that. I'm going to use my newly proved formula. 4 pi squared r over t squared. Just make sure I have everything I need here, so I'll fill it in. 4 pi squared. My radius is 384,000 times 10 to the 3 meters. That's not squared, so don't square it. And your period is 2.36 times 10 to the 6 squared. So your AC value, when everything is said and done, is 2.7 times 10 to the 3 meters per second squared. Now that doesn't feel right. That feels way too big. So let me just see here. 4 times pi squared times 384,000 exponent 3 divided by 2.36 exponent 6 squared. Aha, I thought there was something up there. That should be a minus. Okay, so there's your acceleration towards the center of the Earth. So if this is the moon here, it's accelerating this way towards the Earth.